we present MVLift, an approach that generates 3D motion without training on any 3D motion data. Our framework only needs 2D pose sequences extracted from monocular videos. Given a 2D pose sequence, MVLift estimates complete 3D motion, including joint rotations and root translations, and our approach is applicable across various domains like human poses, human-object interactions, and animal poses. Our key insight is to reformulate 3D motion estimation as generating consistent multi-view 2D pose sequences. Learning to predict multi-view 2D pose sequences with direct supervision would require a dataset containing consistent multi-views of the same motion, which has very constrained availability, similar to 3D motion data. To address this challenge, we propose a novel framework that uses 2D motion diffusion to progressively establish multi-view consistency. The key advantage is that it only requires readily available single-view 2D sequences extracted from videos. Our framework progressively builds multi-view consistency through 4 stages. The first 3 stages prepare training data for stage 4 by gradually introducing stronger multi-view constraints. This synthetic data, with consistent multi-view 2D motions, is used to train our final stage, a multi-view 2D motion diffusion model that directly generates consistent multi-view sequences with a single forward pass. The process begins with line-conditioned motion diffusion in stage 1, establishing basic epipolar constraints. Stage 2 optimizes for rough multi-view consistency, while stage 3 generates strictly consistent synthetic data. Finally, stage 4 learns to directly and efficiently predict consistent multi-view 2D motions from a single input sequence. Next, we show some comparisons of human pose lifting. First, we compare MVLift with 3 baselines that do not require 3D motion data during training. As shown in the video, Pose and Mass produce unrealistic poses and cannot predict root translation, while Simplify generates motions with sudden changes in depths and poses. Our results showcase more realistic human motions. We also compare with 2 baselines that require training on 3D ground truth motion data. The results show that the baselines struggle to generate realistic root translation, while ours can predict more natural root trajectories. For animal pose lifting, we compare against 2 baselines. Given a sequence of 2D key points for a cat, Simplify produces results with sudden changes in depths, while Mass results contain severe artifacts and lack root translation prediction. Our results showcase more realistic animal motions. We also evaluate our approach on human-object interaction data. As shown in the video, the baseline results show incorrect contact between the human and object. Some frames contain unrealistic human poses and sudden object translations. Our approach generates more realistic interactions with plausible hand-object contact. Thanks for watching.